So stability of KMnO4 in water. So I request you all of you to be engaged with me to discuss the topic over here. This is very important because this KMnO4 you use in the redox reactions, and this is one of the important oxidizing agent. And I'm going to discuss again the stability of KMnO4 in water. So KMnO4 mean here, this is the MnO4, KMnO4. So if I ask what would be the half cell of water to be considered to discuss the stability of KMnO4, what would be your answer?
So minus 0.8277 वाला.
-0.8277.
चलो और बताएं.
So 1.2291.
Okay. Okay. So this is the actually the only way to react KMnO4. Which one? This. The water is this. Always one should be the oxidized form, one should be the reduced form. Both cannot be oxidized form and both cannot be the reduced form. It must always react like this. Now, at the standard conditions, I have just written to confuse you, and in similar way, I will be confusing your quiz or exam, mid or final exam as well. So you must be very confident, and there is, I think, it is very easy to understand the concept over here. So this may only react with this one, and now the possibility over here is to check whether this reaction is spontaneous or non-spontaneous. What would be your answer?
They're non-spontaneous.
How it is not spontaneous?
So because reduction potential of water is more.
How it is more? It
So
is
it-
1.5 and this is 1.2.
Acha, sorry, sir. Sorry.
It is 1.5. Okay.
Haan ji, sorry.
1.5 minus this, you must have the positive value,
So it will be spontaneous.
and then it would be a spontaneous. Of course, it would be a spontaneous. Now the question over here is, you prepare KMnO4 in water right from your intermediate. Then if it is the spontaneous, this will react with water, and of course it will react with water depending on these cell potentials value. And now what is the possible answer over this? How you can avoid this spontaneity, because you have to prepare KMnO4 in water, and without water you cannot prepare the KMnO4. So what would be your answer over here?
So by changing pH.
pH को
We
change
will change the
करेंगे.
pH.
Change the pH.
We will
Either
increase.
there is only two options over here. One is if you can reduce this potential. This is also one of the option is available, but right now we are discussing the pH. Or you can change the pH of this half cell. There are the two ways. Okay. So what would be the nurse, if you can write the nurse equation of this half cell, the KMnO4. So the both way I have presented over here is given, whether you can change the concentration of MnO4. Again, this is the standard mean 1 molar concentration of MnO4 and 1 molar concentration of manganese plus 2 and 1 molar concentration of the hydrogen ion. And if it is not 1 molar, then it would be non-standard condition. So how can you reduce this one? This is one of the option. By reducing this, you can increase the concentration of Mn plus 2, or you can decrease the concentration of KMnO4 or the hydrogen ion. Then this cell potential will decrease. So when you are free, just look at this one, take into example, put any values, you will easily understand. By increasing this whole factor, this is going to decrease because this is having the minus sign. If it is a plus, then if you increase this one, this would increase. So it is an inverse relationship due to this minus sign. So what would be the answer? Now you can increase the pH or you can decrease the pH, or simply you can say because here the hydrogen ion is here and the hydrogen ion is also here. And simply I am using the term, you can change the pH. And if you change the pH, of course, you will use the acid, okay? Because you have to use some the acids. So now I am using the HCl as I said to change the pH of the solution. Okay. So if you use the HCl, then what would be the reactivity of KMnO4 with the this acid? Acid mean it is having H positive and Cl, because H positive is having the potential of this, and Cl, this is the half cell of the chlorine, this is having the potential 1.358. Now again, either this will react with this hydrogen, never, because both are the oxidized form. There is only one way. So that means MnO4 is stable in the presence of the H positive. Now either MnO4 will react with the chlorine. What is your immediate answer? Either
Sir,
again,
करेगा.
correct. And this is the spontaneous reaction, because 1.507 minus 1.358, you will get the answer in plus. So that means if you use the hydrochloric acid to maintain the pH by in case of the MnO4, this is again going to react with the chlorine. So that means all acids are suitable. So HCl is not suitable for the KMnO4. It may be suitable for another metal ions or the hydrogen ion, any of the metal ion concentration. So I'm going to change the acid. Now I'm going to use the H2SO4. So H2SO4 again, this is having two half cell, one is the H positive, other one is the sulfate. H positive is given over here. This is the sulfate half cell, S2, it is S28 forming plus 2 electron converted into the sulfate, or sulfate when oxidized is converted into S28. Now check the possibility whether this MnO4 will react with sulfate or not.
No, sir. No, sir, it won't react.
It will not react, because this is again, this is the cathode minus anode. You will get the answer in minus. Minus mean this is not going to react with the sulfate, and of course MnO4 is not going to react with the H positive. So now you can use the H2SO4 to maintain the pH of the KMnO4. So that is the reason we use the sulfuric acid, not HCl, while preparing the KMnO4 solution. So this is the scientific reason behind this one. And in a similar way, you can explore the rest of the preparation of these solutions. So this is all about our today lecture. And I will start with the, maybe I will discuss some biological, or maybe I will start with the new topic in the next